Hello Gems! Welcome back to the Super 30 series. In this series, we are discussing 30 most probable questions for BITSAT 2024. Okay, so with every video, we are discussing about 30 questions which are probable to appear in your BITSAT 2024 exam. Okay, so this is video number 2 or session 2. If you want to check out the previous session, the links are available in the description box of this video. And this series is going to go on for a few months now, 2 to 3 months, and we'll be doing about 10 videos, so 300 questions. So if you are interested, you can consider subscribing and join in for free. With that being said, let's begin with today's video. And 2 of our session today. So question 1 is from units and dimensions. Now as we go through this session, whenever necessary, I'll drop in and I'll tell you what are the important parts from a certain chapter. Okay, like for question 1, it's from units and dimensions, and the important part from this chapter is dimensional analysis. You are supposed to know how to find the dimensions of different quantities, and also one more important part is having to do with your errors. Okay, so these two are the important part, and questions are being frequently asked from here, these two parts, in units and dimensions for BITSAT. Okay, so let's come to this. The dimensions of which base quantity corresponds to this. Okay, these letters have their usual meaning. G is universal gravitational constant, H Planck's constant, C is the velocity of speed, okay, or speed of light. Okay, so let's find this out. If you know the direct dimensions of G and H, good for you, just substitute and get the answer. Okay, or else you can use the formula F is equal to G mm by r square, and from here we can find the dimensions of force, mass into acceleration, mlt raised to minus 2. Then dimensions of G, which we are supposed to find, it is a dimensional constant, mm, so that makes it m square, right, and radius square or length square. Okay, so if you want to find the dimensions of G, you can see it will be m divided by m square, that is m raised to minus 1. Okay, L into L square, that is L cube, and T remains the same, no T on the other side. So these are the dimensions of G. Let's find the dimensions of H now. Okay, H, we can use the formula E is equal to H nu. Now energy is mlt raised to minus 2, right? Mass into ml2 t raised to minus 2. Okay, mass into velocity square. Okay, half mv square. So mv square, and H we are supposed to find, nu is t raised to minus 1. Okay, so it's simple, 1 t raised to minus 1 will cancel and we'll be left with ml2 t raised to minus 1. These are the dimensions of Planck's constant. Okay, you might know it by heart, good for you. And finally dimensions of C, it's basically velocity, so L t raised to minus 1, right? So we can substitute it all in this formula, which is gh by c cube. Okay, so here we'll have m minus 1 L3 t raised to minus 2, and then H, for H we have m L2 t raised to minus 1. Okay, and for C cube, right, cube, so cube this, L3 t raised to minus 3. Okay, now we can note that this is m minus 1, this is m, so this m and this m will cancel out each other. T raised to minus 2, t raised to minus 1, t raised to minus 3 in the numerator, t raised to minus 3 in the denominator. Okay, so we are left with lengths. Okay, and we can see that it will become, this will be L to the power 5 upon L to the power 2, L to the power 3. So that will make it L square under the root, and that will give us the dimensions of length. Okay, so these corresponds to dimensions of length. Okay, so option B is the correct choice over here. Let's come to this one. This question says the force on a body of 1 kg is this. Okay, it's given in vector form in newtons. If it starts from rest, so U is given. So write down the things as we go through the questions. Then the position of the body. So basically you are supposed to find S. Okay, these type of questions are usually common using your uniform accelerated motion, right? Those 3 equations of motion. Okay, so here you are given force, right? Force of a 1 kg body. So it's also the acceleration, because you know acceleration is force by mass, right? Since mass is 1 over here, so acceleration, basically force is equal to acceleration. Mass is 1, right? So this is nothing but your acceleration, 20 I cap plus 10 j cap. Okay, fine. Now you are given u is 0, you are just supposed to find position at time t. Okay, so you are supposed to find s. Sorry, this is something you are supposed to find. Okay, so s will be given as ut plus half at square, but this is 0, right? U is 0, so I can simply write s is equal to half a t square in vector form, of course. Okay, so half, and we have a, which is this 20 I cap plus 10 j cap, and t square, which is time is 2 seconds, and that square, the square and this one will get cancelled. You'll have 1 2 over here, so multiply it, 40 I cap plus 20 j cap. Okay, so our answer will be option D, 40 I cap plus 20 j cap. Okay, so that's your answer. These were the two questions. Let's move to the next set of questions. 3 and 4 now. In question 3, we are supposed to find the equivalent capacitance between A and B. Now from electrostatics, capacitance topic is important for BITSAT. I am expecting at least one question from capacitance in one of the shifts of 2024. Okay, so let's come to this question. So in order to find the equivalent capacitance between A and B, actually you can imagine that you can bring C1 like this, C2 and C3 like this. So it's again between A and B, and C4 also like this. Okay, so you can see that these three branches, 1, 2 and 3, the three of them are in parallel. Okay, so if you have hard time imagining that, I'll also give you some different approach. So this is point A, right? So we can consider the potential at this point as A. Okay, so you can see that this point A is directly connected to this point. Okay, there is no resistor, a capacitor or anything in between, right? It's a simple wire. Okay, so if the potential over here is A, potential over here will also be A, right? Logical, there is no potential drop across a conductor, right? So here it is A, then here also it is A. Similarly, if here it is B, it is connected by wire to this point, so this point is also B. Now if we can reconstruct this circuit, you can see that this C1 is between A and B. Okay, so let's draw that. C1 is between A and B, so let's consider this point as A, this point as B. So C1 is between A and B. Now you can see this C2 and C3 together, their series combination is between A and B. So again C2 and C3 we have between A and B, and finally C4 is also between A and B, right? So C4, so now you can see that all three branches are between A and B, which means they are parallel. Okay, so we can find the equivalent easily. C equivalent in parallel we add, right? So C1 is 1 plus C2 and C3 are in series with each other, and then they are in parallel with C1 and C4. Okay, so C2 and C3 in series, so that will make 2 and 2, so basically makes it 1, right? So 2 and 2 divided by 2 plus 2, that will make it 1 plus C4, right? So 1 this branch plus this branch, so 1 again. Okay, so this is 1, this is also 1, 4 divided by 4, which is 1, plus 1, so that is 3 microfarad, which is option A. Okay, so let's come to this one, question 4. An ideal monoatomic gas, we have it at 300 Kelvin, expands adiabatically, so to twice its volume. Okay, you are supposed to tell the temperature of the gas, so final temperature of the gas. Okay, so adiabatic is given, so PV raised to gamma is constant. Okay, we can find the value of gamma because it's a monoatomic gas. We can find gamma for monoatomic gas. Okay, now we are given the relation between temperature and volume, right? We are speaking of temperature and volume, so we don't want pressure in this term. We can use the ideal gas equation since it's ideal gas, so we can write PV is equal to RT for 1 mole basically, or nRT, whatever you want to write. So P will become RT by V. Okay, so P will become RT by V. Okay, so you can see that your R is constant. Okay, R is constant, so I can basically say P is proportional to T by V. So I can replace this P by T by V. Okay, because this is constant, only the constant will become different. Because we have R, we can take it to the other side, so the constant value will change, but still this quantity will remain constant, right? Or some of you might directly know the relation for adiabatic between temperature and volume is this, right? V, and here we have gamma and V raised to 1, so V raised to gamma minus 1 is constant. Okay, this is the relation for adiabatic process between temperature and volume. This is pressure and volume. Okay, and this is how you derive it, short derivation. Just use the ideal gas law. Okay, now we can write T1 V1 raised to gamma minus 1 is equal to T2 V2 raised to gamma minus 1. Okay, because this is constant, right? Initial equals final we are writing, and we are supposed to find the final temperature. So T2 we are supposed to find. So T2 will be T1 V1 raised to gamma minus 1 upon V2 raised to gamma minus 1. Right, so we know that T1 is 300, initial temperature is 300, and we can write V1 by V2. So initial volume is 1. If initial volume is 1, it becomes twice its volume, right? So V2 is 2 times of V1. So we can write V1 as V1 and V2 as 2 times of V1. Both are raised to gamma minus 1. Okay, so 300 into half raised to gamma minus 1, which is close to this one, right? So we'll also get the value of gamma for monoatomic gas. In terms of degree of freedom, you can write a gamma is 1 plus 2f. So this will give us 1 plus 2, and degrees of freedom for a monoatomic are x, y, z, right? 3. So 1 plus 2 third. So instead of adding and subtracting over here, I can directly write gamma minus 1 as, you can take this 1 to the other side, you'll get 2 third, right? So this T2 will be nothing but, since you have the value of gamma minus 1, so 300 half raised to gamma minus 1, which is 2 third. Okay, so 300 half raised to 2 third, option C. Okay, simple concept, just use the temperature volume relation for adiabatic process and get your answer. Okay, so that's question 3 and 4. Over to the next set of questions. Time for question 5 and 6. Question 5, an X-ray is operated at 15 kilovolt. Calculate the upper limit of the speed of the electron striking the target. Okay, so here you are just supposed to equate this energy out of this kilovolt, 15 kilovolt, to the kinetic energy. So basically EV is equal to half mVe square. Okay, from here you can find V. Now I chose this question because it is slightly calculative. It's a old BITSAT type question. Okay, therein the old questions of BITSAT were usually calculative. Okay, so if you encounter such type of question in your exam, don't leave it because it is calculative. You can do some jugad. I'll tell you how. So if you see here, VE will be under root 2 EV, E into the voltage divided by M. Okay, M is the mass of electron. Here you are supposed to know all the constants. So 2, of course you know 2. Then E is 1.6 into 10 to the power minus 19. V is the voltage, which is 15 kilovolts, 15 into 10 to the power 3 volts, and divided by mass of electron. Okay, mass of electron is 9.1 into 10 to the power minus 31, right? So now let us solve this. Okay, now you might say that this is calculative and you might just end up leaving the question. Okay, don't do that. You can see the answers are very far away in their orders of magnitude, right? 10 to the power 7, 9, 10, 6. Okay, so you can do some approximations. Okay, so we'll exactly do that. So 2 into 1.6 we'll say into 15, we'll get this on one side, and this is 19, and this will become 31 plus what? 31 plus 3, 34. 34 and 34 and 19. 19 plus what is 34? I think 15. So here we'll get 10 to the power 15. Okay, so this is simple now. Not so much, but yeah, we'll approximate. So what we'll do, we'll say 2 into 15 is 30, right? And 1.6 we can shift the decimal, say it is 16, and what we can do, we can say, so we have multiplied, we have used 1 power of 10, right, in doing that, and here we'll have 9.1. Okay, so 30 into 16 divided by 9.1. Okay, and that is 10 to the power 7. You can see that 10 to the power 7 option is over here. Okay, you can verify that this is about 7. Okay, so if you see, this is 16 3 is 48, right? So it is 480 by 9, something like that. So that will come out to be around 7. Okay, so that is 480 by 9. Let us try that. So 9, how much? 9 5s. So this is under the root, right? So 5s and about 50 you will get. Okay, so 5s and 3, so 3s are 27, right? 53, so around 7 point something more, right? 49 is 7, so square root of 49 is 7, so this is around 7ish, 7 point something something, and into 10 to the power 7, which is option A. Okay, so even if it's calculative, try to approximate and reach to the answer. Okay, don't leave the question because it is calculative. This is an old BITSAT question, but I just wanted you all to prepare for such circumstances. Okay, that's why I chose it. Let's come to this one. Here we have a steel wire, its elastic limit is given. Okay, so limit meaning stress is given. Okay, you can see the units, Newton per meter square. Cross section area is given. The maximum upward acceleration that can be given to it if it is pulling up a elevator of mass 1000 kg. Okay, so it is going to pull up a elevator, a lift of 1000 kg. Okay, and for doing this purpose, we are using 1/4 of the elastic limit. Okay, of course, for just to pull the elevator, we'll use 1/4 of the elastic limit, so that when people stand in it, it does not break. Okay, if we use the total limit just for the elevator, if people stand in the elevator, it's going to break, right? So we are going to use 1/4 of the limit for the elevator, and then people can also use it, right? So first of all, let's calculate 1/4 of that limit. So this is the limit. So 2.8 हद पार कर दी. So this is the limit, and we are taking 1/4 of it. So okay, so that will be this is 0. This is 5s are 20, and again we'll have 2. So 5s are. So I can write it as 5.5 into 10 to the power 7. Okay, this is the limit for the R lift. Okay, this is the stress that maximum stress that the string can take when it's pulling up the lift. Now we can equate this stress. Okay, we can say this is force per unit area, right? This is stress. Okay, Newton per meter square. Okay, we are supposed to find acceleration. Acceleration we can find using force. Okay, now area is given, you can find force. From force you can find acceleration because you know the mass, right? One more important point is that it is pulling up the lift, right, under the influence of gravity itself. Okay, so when it is pulling up, you know that when the lift is going up, you can yourself feel it. When you are moving up in the lift, you feel yourself to be heavy, right? Because here in this case the acceleration is g plus a. In the case the lift is going down, you will feel weightlessness. Okay, weightlessness in the sense your weight will become slightly less. Okay, factually. Okay, so that will be g minus a, but when going up it is more heavier. Okay, g plus a. You can prove that using the concept of pseudo force. So here the acceleration on the string is g plus a. Okay, so basically g is in the downward direction. If you go in the frame of that lift, you have to apply it in the upward direction. So a is also in the upward direction, g is also in the upward direction, a plus g. Okay, so force is m into g plus a. Okay, that's why g was given over here. And area, so we can directly multiply it to the other side. So 5.5 into 10 to the power 7 into area. Area is 4 centimeters square. So 4 into 10 to the power minus 4 in meters square. Okay, we are keeping everything in meters, and this m is 1000. So g plus a is, this is 5.5 into 4, again that 1/4, and this could have cancelled instead of doing the drama. Okay, and we can divide by m, which is 1000, again 10 to the power 3. This and this will get cancelled. This 5.5 into 4, that will give us 22, right, yes. So 22, and g plus a is 22, meaning a is 22 minus 10, which is 12. Okay, so option D, 12 meters, is the correct choice over here. Okay, I hope the concept was clear. You are just supposed to use the stress formula and the concept of pseudo force. Okay, the force will be m into g plus a. Okay, I hope that is clear. Let's move to the next set of questions. Question 7 and 8 over here. Question 7 is from AC chapter, alternating currents. Now this chapter is not that frequently asked. It's just asked once in a while. Okay, once in 2 years maybe. So here the questions are usually based on power factor or your LCR circuits or LR circuits or the different circuits that you get in AC. Okay, so in question 7 we have an LCR circuit. We are told that the AC source, this is the AC source, provides this AC waveform, okay, you are supposed to tell what will be the voltmeter and ammeter reading in this case. So you are supposed to tell the voltage across these three elements and the current in the circuit. Okay, it's very simple because because your current IO, the peak current we can say, is VO by Z. Okay, Z will be given as under root of your basically your resistance is R square plus XL minus XC the whole square. Okay, so let us find XL and XC first. The impedances due to your uh, due to the inductive element and the capacitive element. So XL we can find it over here, omega L. So that is omega. If you see, you can compare this with V is equal to V0 cos omega t. Okay, this is not omega, sorry, this is 2000 t. Okay, so 2000 is omega. So 2 into 10 to the power 3, I can write it that way, into 5 into 10 to the power minus 3. Okay, this power and power 3 and power minus 3 will go 5 to the 10, right? So 10 ohms, of course. Then we have XC. Let's calculate XC now. XC will be 1 upon omega C, okay, which is 1 upon 2 into 10 to the power 3 into C, which is 50 into 10 to the power 6, 10 to the power minus 6. Okay, I can take it on top, say it is 10 to the power 6. Okay, so that will, I think, again give us so if you see, this is 5 to the 10, 50 to the is 100, 100 is 10 to the power 100 is 10 to the power 2, and this is 10 to the power 3, so 10 to the power 5, and that will cancel out with the 10 to the power 6 and will be left with 10. So you can see that XL is equal to XC. Okay, XL is equal to XC, meaning this is resonance. Resonance meaning only the resistive component will function in the circuit. Okay, the everything, this effect is being cancelled, the inductive effect is being cancelled by the capacitive effect. XL is equal to XC, only the resistor will work in the circuit. So basically your I naught will be the result of V naught by R. Okay, now for current we have to use both the, because current is seen in the circuit, so 8 plus 2, the complete resistance, they are in series, right? Same current flows, no current in the voltmeter branch. So V naught, the maximum voltage is 20. R is what? R is 8 plus 2, 10. So that will give you 2. Now this is the peak current. Okay, whenever you report the, what your ammeter reports is the RMS values. Okay, so RMS, IRMS will be I naught by root 2. So this value by root 2, so that will be root 2, right? So about 1.4. There is that. I think this option, right? 1.41 amperes. Okay, let's verify the voltage also. Voltage across this three elements. Okay, this is not contributing, this is also not contributing, rather they are contributing but cancelling each other. Okay, so V across your 2 ohm resistor, we can say, right? We just want V across 2 ohm resistor will be I, current which is coming out of the circuit, and that times you can say I RMS, directly find the RMS value only, so that we get the voltage. So I RMS into your 2 ohm resistor. Okay, so I RMS is 2 root 2, right? So 2 root 2. 2 root 2 is 2 times 1.14, which is 2.82. So option B, 2.82 volts is the voltage drop across this, and 1.14 is the current drawn from the source. Okay, so those are the values on your ammeter and voltmeter respectively. Okay, let's come to this one. Here we have three particles, each of mass m, placed on the vertices of an equilateral triangle. Side is L, each side length is L. The moment of inertia of the system about a line AX. Now we have a line AX perpendicular to AB in the plane. Okay, it's in the plane. So we have suppose this is a triangle, suppose, okay, and here we have the line AX. Okay, this is the vertex A, B and C. Okay, so here we have the line AX. Okay, so it's in the same plane, it's not perpendicular like this, it's perpendicular in the same plane. Okay, so it's in the same plane as that of the triangle. Okay, you're supposed to find the moment of inertia about this line AX. Okay, now you can see that these are discrete masses, so moment of inertia will be basically I1 plus I2. Okay, sum of the moment of inertia due to individual masses. Okay, So first of all, we can see this at point C it is. This point will not contribute, it's on the axis only these two will contribute. So if you see, this distance is L square and the mass is m at a distance of L square, ml square, right? Now again, this point, it is m, mass is m, and at a distance of L square. No, that is wrong. Okay, the distance over here is this distance perpendicular distance from the axis. If you see, this is the perpendicular distance from the axis. Here also consider the perpendicular distance from the axis. So if you can see, this is an equilateral triangle, meaning this angle will be 60 degree, and this side if you want is adjacent to theta, right? Adjacent to 60 is L cos 60. Adjacent to theta is L cos theta. Okay, so L cos 60 the whole square. So this is m L square. Cos 60 is I think root 3 by 2. Yes, and the square. So m L square. You can see the answer now. M L square 3 ml square by 4. Right. So 4 cos 60 sin 30 is half. Cos 60 is half. Sorry. Okay. So this is 1 by 2. So 1 by 4 square. So that will be 5 m L square by 4, which is option D. So option D is the correct choice over here. Okay, so simple addition of moment of inertia. The distance are measured from perpendicular to the axis of rotation. Okay, so those were the two questions, 7 and 8. Let's move to the next set of questions. Question 9 and 10 over here. Question 9, we are supposed to tell a significant result from your Rutherford scattering experiment. Okay, now mark my words, at least one question in the BITSAT paper that you are going to answer will be based on theory. Okay, this is a question where you don't have to think a lot, you will directly know the answer. If you know it, you know it. If you don't know it, you can't do anything about it. Okay, so at least one question will be like that, one or two. Okay, that is the trend that we are seeing in the recent BITSAT paper. Okay, so for that matter, for the purpose of theory, BITSAT becomes a syllables completion game. That's why you are supposed to cover up more syllables for BITSAT than for JEE. Okay, so complete your syllables well and know the theory very well. Okay, at least one question will be theory based. Okay, and for that reason, your chapters like atoms, the modern physics chapter, dual nature, or your atom or nuclei or even semiconductors become very important. Semiconductor is an important chapter. At least one question comes from that chapter if you see the recent BITSAT papers. Okay, from 2016 it's always consistent. Okay, one question from the semiconductor chapter, usually based on theory. Okay, let's come to this question. Here you are supposed to tell the result from scattering experiment. Okay, so you can clearly see that the answer over here will be option A. Okay, most of the positive charge is at the center of the atom, right? Rutherford concluded that most of the atom is empty because most of the alpha particles pass through the gold foil without scattering, right? Only few of them, right, like I think 1 in 18,000 or 1 in 20,000 were deflected by an angle of 180 degree, which means the positive charge is densely concentrated at the center. Okay, and most is empty because most of the alpha particles just pass through. Okay, if you see the other options are very dumb. Neutrons were not a discovery of Rutherford. Alpha particles are helium nuclei. That was a fact. Okay, that was not a discovery of Rutherford. And electrons embedded, that is something Thomson proposed, right? So option A is the correct choice over here. Let's come to this one. This is a question based on motion in 2 dimensions. Motion in 2 dimensions, 80% of, I think 80 or 95% of the chapter is projectile motion, right? And the most important part is the first part of the chapter, okay, wherein you learn those 3 formula: time period, which is the time of flight, the height, maximum height achieved, and the horizontal range. Okay, these are the 3 important formulae that you are supposed to know. Most of the questions in BITSAT are based on that and simple concepts here and okay. So here we have a gun which fires 2 bullets at 60 and 30 degree. What's so special about these 2 angles? They are complementary angles. Okay, so for complementary angles, you might know that the horizontal range is the same. We are going to use it. The bullet strikes at some horizontal distance, the ratio of the maximum height of the 2 bullets. So maximum height achieved by these 2 bullets is in the ratio. Okay, So first of all, we know that these two are complementary angles. 60 and 30 are complementary. So r of 60 degree, the horizontal range of 60 degree is equal to 30 degree. Okay, because they are complementary angles. Two complementary angles have the same horizontal range. Okay, for a given projectile motion. So here we have u1 u1 sine u square sine 2 theta. Okay, don't forget the formula by g, and here also u2 sine u2 square sine 2 theta dash I can say, so this angle is different by g. Okay, so this and this will get cancelled, and we'll have we can get the ratio of u1 square here sine 2 theta sine of 2 times of 60 sine of 120. Okay, and here you will have u2 square and sine of 30, sine of 30 into 2, right? So sine of 60. Okay, sine of 60 is root 3 by 2, and sine of 120, sine of 120 can be written as sine of 90 plus 30, right? Sine 90 plus 30 is cos, sine in the second quadrant positive, 90 meaning cos, and 30, cos 30 is root 3 by 2. So both of these are root 3 by 2, root 3 by 2, which means u1 square is equal to u2 square, or simply u1 is equal to u2. Okay, u1 is equal to u2. That is what we obtained from our range equation, and we are supposed to find for height. Okay, we did this because we wanted to find a relation between u1 and u2. Okay, and now we can find for height. Height is u square sine square theta by 2g. Okay, these formulas are important for BITSAT. Okay, so height, you can from here you can directly see it's directly proportional to sine square theta, right? Because u is same in both the cases and g is a constant. So if you take the ratio h1 by h2, those two things will cancel out. Okay, so you can say h1 by h2 is sine theta by sine theta dash, I use dash, right? So sine theta dash the whole square. Okay, so sine of 60 is root 3 by 2, and second case sine of theta dash, which is sine of 30, which is half, and that square. Okay, so if you see 2 and 2 will get cancelled, you will have root 3 square, which is 3. So the ratio is 3:1. Okay, 3:1, option B. Okay, so that is how you do it. You are just supposed to know the concept that two complementary angles will have the same horizontal range. Then you can use the height formula. Okay, so that's about this two questions. Over to the next one. Now time for question 11 and 12. So we are 1/3 done with our video. So let's continue. So here we have one more of ideal diatomic gas. It is undergoing this process. From this you can see V is directly proportional to 1 by T. V is directly proportional to 1 by T, or you can say V times T will be constant, right? V is equal to K by T you can write, and you can bring K or T to the other side. So Vt is constant. You are supposed to tell about the molar specific heat capacity. So you are supposed to tell about the C over here. Okay, in the process, not Cp or Cv, basically C. Okay, simple C that appears in the formula of heat. Okay, now this is a very standard question. Okay, I'll do it. I'll also tell you the logic as we go through. Okay, it might not sound logical when we are doing it, but when we connect the dots behind, it will seem logical. This is the first thing that we are going to do is differentiate this. Okay, differentiate this. So u into v we can use. So v dt plus t dv, right? U into derivative v plus v into derivative u. Derivative of constant is 0. Okay, we are doing this because we want dv in terms of dt. Okay, we'll use it somewhere. So dv is minus v dt upon t. Okay, minus v dt upon t. We are going to use this somewhere. Okay, basically we wanted dv in terms of dt. Okay, now let's use the first law of thermodynamics. The heat provided will go in increasing the internal energy, and some amount will do work. Okay, so now dq can be written as the heat. If you define your specific heat, it can be delta q by n delta T, right? You see delta T. Okay, so dq will be n into delta T. N is 1 mole, so basically C into dt you can. Okay, C into dt will, n is 1, C into dt will give you dq. Okay, similarly du you should know the formula. Du is internal energy. Internal energy is a function of temperature, so ncv delta T. Okay, and again 1, so cv delta T. Okay, this is at constant volume. Okay, here you are supposed to know all the thermodynamics formulae. Okay, plus dw, which will be pdv, right? So that is why we wrote this dv in terms of dv. Okay, dv is the work done is pressure into change in volume, right? P delta. Okay, so now dv can be substituted, and you can see that dt will cancel out throughout. So cv dt and p dv. dv is minus pv by t. This p by t and dt. Okay, so simply we get over here dt can be cancelled out throughout the differential. So c is equal to cv minus pv by t. Okay, okay, pv by t. So for ideal gas we can write pv is equal to rt, right? 1 mole, so n is 1, pv is equal to rt, pv by t is r, pv by t is r. Okay, so this is nothing but r, and what is this? cv. cv for a diatomic gas. For a diatomic gas, now we are very close to the answer. cv will be fr by 2. Okay, in terms of degrees of freedom, fr by 2. Okay, so fr by 2. F is 5. For a diatomic gas, we have x, y, z and 2 rotational degrees of motion, right? So 5 r by 2. So 5 r by 2 minus r, so that is 3 r by 2. So the correct option over here is option A. Okay, now we can connect the dots backward and it will seem logical. We did this because first of all, from the graph we can deduce this, right? Vt is constant. So we did this dv in terms of dt so that we can substitute in pdv. Okay, because we wanted everything in terms of dt, and that can cancel out and give us in terms of r only. Okay, cv is fr by 2, f is 5 for diatomic gas. Okay, excuse me, sorry. So let's come to question 12. Here for an insulator we are supposed to tell the energy band gap. Okay, so the band gap energies. So again a theory based question. If you know, you know. If you don't know, you can't do anything about it, right? So here for semiconductors, for first of all for metals, the band gaps are overlapped, right? The valence band and the conducting band are into each other, I mean over each other or whatever. Why am I making it worse? Okay, so here for semiconductors the energy band gap is about 3 electron volts. Okay, it's 3 or less. Okay, less than 3 electron volts, max can be 3. Okay, less than 3 electron volts. Okay, and for your insulators it will be something greater than that, or ideally it will be greater, about 5. Actually 5 is the answer over here. So ideally this is about 3 and this is greater than 3. Only one option, which is option B, 5 electron volts. Okay, for insulators the energy band gap is more, hence there is no transition from the valence band to the conduction band. Okay, so that's question 11 and 12. Over to the next question. Now discuss question 13 and 14. In question 13 we have it from electromagnetic induction. We are given the resistance of a coil is 50 ohms. Okay, the induced current as a function of time is plotted as shown. You are supposed to tell the magnetic change in flux through the coil. Okay, so first of all in EMI we know that the EMF induced will be delta phi by delta t, right? The rate of change of flux, or I can write d phi by dt. The minus sign is due to opposing nature. Let's ignore that. Okay, we are just supposed to find the change in flux, right? The magnitude. So here d phi by dt will be equal to IR, right? The voltage is also given as IR in terms of resistance that they have provided. Okay, now what we can do, we are supposed to find d phi. So d phi will be I dt r. Okay, and we can integrate on both sides. Okay, we'll know why we are doing this. Okay, r is constant, you can get it out of the integral also. So if you see, this integral I dt is nothing but area under IT graph, right? Integral is nothing but the area under IT graph. I dt will be area under IT graph. Okay, so d phi will give us phi, which is the flux that we are supposed to find, the change in flux. and the total change in flux, and here we'll have R times the area, right? R times area. Let us substitute the values. R is 50, area is half base into height. You can see a triangle over here, so half, this is right angle triangle, right? So half, height is 8 and base is 0.2. Okay, so this will make it 0.1 and this 10 with that. So 5 into 8 is 40 Webers. Okay, everything is in standard units, ampere time. Okay, so 40 Webers is the correct choice over here, option. Okay, quite straightforward. Just know the logic that area integral is nothing but area under the curve. Okay, let's come to this one. This is from current electricity. Now questions on current electricity are usually based on finding the equivalent resistance. Okay, equivalent resistance, equivalent current in the circuit. Okay, those type of questions are usually asked from current electricity. So here you are supposed to find the current in the 2 ohm resistor. So for that, first of all, we'll need current, the total current in the circuit. Then we can split it among the resistors, right? So if you see this branch has capacitor in it. Okay, usually when you consider a capacitor, if you see a capacitor in the circuit and it's not mentioned anything about it, you consider it in steady state, fully charged. Okay, fully charged meaning it will accept no more current. Okay, so you can break it open. Okay, you can open that branch of the circuit, you can ignore that branch. Okay, ignore that branch which has the capacitor. Okay, so I is the current. Now you are just supposed to looking at the simplified version of the circuit, right? 3 and 2 in parallel and in series with 2.8. Okay, so R equivalent, so we can find R equivalent first and then I. So 2 and 3 in parallel, 2 3 plus 2 plus 3, which is 5, and plus 2.8, right? So this is 6 by 5. 6 by 5 is 1.2. 1.2 plus 2.8 is 4. Okay, so this is the R equivalent, 4 ohms. Now I will be V by R equivalent. This is the current drawn from the circuit. So V is 6 and this is 4. So 3 by 2, which is 1.5 amperes. Okay, this is the amount of current that is drawn from the circuit. This is this I. Okay, I is 1.5 amperes. Now this current will split, right, into I1 and I2. We are supposed to find I1. Now you can use the current divider formula and you can directly find it. So some of you might know the formula, some of you might use I1 R1 is equal to I2 R2, equating the potential. That is also correct. Okay, or I'll give you a simple logic. Okay, just divide the total current. So total current is 1.5 divided into 5 parts. Okay, 5 because 3 plus 2. Okay, divided in that many parts as equal to the sum of the resistances in the branches. Okay, so we divide it by 3 plus 2, which is 5. 1.5 total current divided by the total resistance, 3 plus 2, 5. Okay, now if you want to find the current in the 2 ohm branch, it will be inversely proportional to its resistance, right? So you have to multiply the other resistance, which is 3. Okay, so if you want to find the current in this branch, multiply the other resistance. Okay, this is also the current divider rule. Okay, so 5 will be 3s are, right, 0.3, and this will be, so this is I1, right? So this is 0.3 into 3, which is 0.9 amperes. Okay, so option B, 0.9 amperes is the correct choice over here. Okay, so that is the way you do it. Over to the next question. Now coming to question 15 and 16 over here. Question 15, we are going to drop a ball vertically from a height d above the ground. If it hits the ground and then loses some energy and then such that it bounces back to half the height, okay, d by 2, the velocity varies with h. H is height above the ground. Okay, so the relation between v and h, the plot of v versus h. Okay, now this is from motion in one dimension. Now as far as your motion in one dimension is considered for BITSAT, the important part is motion under gravity. Okay, the 3 equations, first of all uniformly accelerated motion, the 3 equations, and also the motion under gravity part. Okay, so wherein a ball is dropped from a balloon, or a ball juggler is juggling the ball, so those type of questions are important. Okay, based on gravity. Okay, motion under gravity, basically you can search the topic. Okay, so let's come to this question. Here we are dropping the ball and we are supposed to tell the plot of v versus h. Now we can see, we can use the equation of motion, v square is equal to u square plus 2as and you'll see that v square is u is 0, okay, drop meaning u is 0. Then we have v square as minus 2gs, right, or 2gh we can say, because it's the height. You can see that v is proportional to, v square is proportional to h, okay, or minus h, okay. So this is a parabola, okay. You can see that each of these graphs are a parabola within themselves, right. So this will give you a parabola, and for a parabola, the linear one, this is the square term, right, this is the linear one. So the linear one will open, okay, the parabola opens along the linear term, okay. So you can see that each of this is opening along the x-axis, opens. So if you see opens along the x-axis, okay, opens along the x-axis, opens along the x-axis, okay. So it's like this, and the x-axis is between them, okay. So now let's logically think of this graph, okay. So when we drop the ball, okay, the initially it is at a height d, okay, initially at a height d, the velocity is 0, okay, velocity is 0 initially at height d. So we can say like this, okay. Then it approaches the ground, okay, approaches the ground, finally hits at maximum velocity v, okay. I'll tell you why this graph is the correct one, okay. You can see that none of the other graph, the velocity is reversing in direction. It has to, right, because when it hits the ground, initially the velocity is in the downward direction. When it hits the ground, it has to change, okay. Only this graph is showing that. So logically only this is the correct one, okay. So initially the height is d, okay, height is d, and the velocity is 0, sorry, height is d and velocity is 0, okay, velocity is 0. Then the velocity increases in the negative direction, in the downward direction, and it reaches certain maximum value, right, maximum value, and then the velocity reverses, okay, reverses, it loses some energy, so velocity is slightly lesser, okay, lesser, and then it the height again increases, right, when it hits the ground. Now the height will increase again, so increase again up to a distance d by 2. This is d by 2, half the original distance, okay. In none of the other cases, after hitting, the velocity is reversing, okay. The other graph should have been in the opposite way, okay. They can't be in the same quadrant, okay. That's why the other b c d graphs are wrong, okay, because the velocity has to change the direction, okay. In one case, if it's positive, it has to become negative, okay. So option A is the correct graph over here, okay. Let's come to this one. This is from wave optics. Now for wave optics and ray optics, those are big two chapters, and BITSAT doesn't really prefer one of those topics, okay. I mean, they do not choose just a particular question or particular type of question from those two topics, okay. They can choose anything. Those are two are important topics. They come in every BITSAT exam, but they can choose from variety of topics, and they usually tend to do that, okay. They can ask a question from intensity in interference, they can ask a question on polarization, they can ask a question on YDSE or diffraction or your ray optics, a combination of lenses, or maybe plane mirrors usually not asked, but we can have mirror formula, lens formula, or refraction at a spherical surface, Snell's law. So the what you say, the content is really open. They can ask questions from anywhere. So if you are preparing these two topics, be thorough with all the concepts that are there in these two chapters, okay. So here we have a question wherein we introduce a glass sheet in at one of the slates, and there is a change in the pattern, okay. A thin glass sheet of refractive index this is of thickness this is introduced in the path of the interfering beams in one of the slates, okay. In YDSA experiment, the central fringe, so this creates a path difference, right, whenever you introduce a glass sheet. So this will create a path difference resulting in a different pattern. So the what happens is that it shifts the central bright to the fifth bright original position, okay. So you are supposed to tell the wavelength used, okay. Here the path difference, actually n lambda, will be mu minus 1 into t, okay. This is the path difference created by your what do we call glass sheet, okay. Or you can write lambda as, or you can write n as, actually if you want to find the number of shiftings, you can take the integral value of this, okay. Integral value of this will give you number of fringes shifted, okay. So that can be a different question, okay. Here we are given this, n is given 5, and we are supposed to find lambda. So mu minus 1, so 1.5 minus 1, t is 6 micron, micron is 10 to the power minus 6, and lambda over here, so lambda is what is this, n is 5, right? So this is 0.5 into 6 into 10 to the power minus 6 upon 5. So this will give us 0.1, so 6 into 10 to the power minus 7, or multiply 1000 and divide by 10 to the power 3. So that will give us 6000 angstroms, right? This will become 10 to the power minus 10, which is angstroms. So option A, 6000 angstroms, is the correct choice over here. We're just supposed to know this formula, which is the part difference created due to the glass shift. Okay, so questions from different topics from wave optics and ray optics are being asked for BITSAT every year. Okay, so prepare it thoroughly. So over to the next set of questions. So question 17 and 18 over here. So we are halfway done with our session today. You might pause and take a 5 minutes break and remind yourself that this is the way forward. Obstacle is the way forward. And through these questions you learn a lot, right? You learned a lot today. You learned about few aspects of certain chapters that are important for BITSAT, and you are going to learn more, okay, if you want to continue. Okay, so yeah, remind yourself that good things take time and this is the way forward. Okay, I'll see you on the other side of your 5-minute break. You can take it now. So we'll begin with question 17. Okay, so question 17, the magnetic field at the center of this square current carrying loop as shown in the figure. Okay, you are supposed to tell the magnetic field at the point O. Okay, so so here we can find actually the magnetic field due to this wire first, okay, then multiplied by 4, right? So this wire is carrying 2 ampere current, and this is a finitely long wire, right, 4 centimeters. So for that, the magnetic field at a point this O, which is at a distance of 2 centimeter. Now the distance, be very careful, this will be 2 centimeters, right? This is 4 centimeters, this is 2 centimeter. Okay, so while you are substituting r, don't substitute 4. Okay, see the distance, perpendicular distance from the current carrying wire carrying. Okay, mu 0 I upon 4 pi r and sine theta 1 plus sine theta 2. Okay, this is the formula for your finitely long wire. So finitely long, I said. So this is 45 degrees and this is also 45 degrees because it is a square loop, right? So theta 1 and theta 2 are 45 each. So mu 0 upon 4 pi, we'll keep that separate because that is 10 to the power minus 7. I is 2 amperes. Radius r is this distance, not the length. R is 2 centimeters, 2 into 10 to the power minus 2 in meters. And this is 1 by root 2 sine of theta 1 sine of 45 plus sine of 45. Okay, so that will give us, if you see, this is 10 to the power minus 7, 2 and 2 can get cancelled, and we have 10 to the power minus 2 in the denominator. 1 by root 2 is 2 times 1 by root 2. Okay, so that will give us root 2 in the numerator, and this is root 2 times 10 to the power minus 5. So the correct option over here is option D. No, it is not correct because this is just for a single wire, right? I said you have to multiply it by 4. This is for a single wire, multiply it by 4. So 4 times root 2 10 to the power minus 5 t. Okay, so be very mindful while you are doing the question. So option C is the correct choice over here. Okay, because each of the wire is contributing to an inward field. Okay, if you are asked for the direction, it is clockwise, right? Clockwise, so inward field. Okay, let's come to this one. We have a mass, initial momentum P starting at time t is equal to 0. We have a force F is equal to AT, A is a constant, T is time, is acting in the same direction of the moving particle. So this will increase the momentum. So momentum changes from P to 2P in the time interval capital T. So 0 to capital T, this time interval, momentum changes from P to 2P. Okay, find the value of T. Okay, you cannot directly use the average force formula that changes momentum by change in time, okay, because this force is dependent on time. So you have to use F is equal to dP by dt. Okay, and this force is also equal to AT. Now you can integrate, you can take dP on one side and AT dt on the other side, and then integrate. P changes from P to 2P. Okay, so integration of dP is P, right? and 2p minus p. Limits will be 2p minus p, right? Integration of dp is p and 2p minus p. A is a constant and we'll have this goes from 0 to capital T, right? The interval is 0 to capital T, so this is t square by 2, and when you apply the limits 0 to t, it will be a capital T square by 2. Okay, now this a capital T square by 2 is equal to p, so this will become, so you can find the value of a from here, very simple, right? So p will t will become 2p by a, okay, under root 2p by a, so which is option A. Okay, so we just had to use f is equal to dp by dt and equate it to this and integrate. Okay, so that's about 17 and 18. Over to the next question. Question 19 and 20 over here, so 2/3 of the way done. So question 19, a charge q is placed at each of the two opposite corners of a square. So सबसे पहला काम सुंदर diagram, that is something my teacher used to say. So capital Q and capital Q at the two opposite ends of a square, and charge small q and small q at the two other opposite ends of the square. So if the net electric force on capital Q is 0, you are supposed to tell the ratio of capital Q by small q. Okay, so if you see, let's consider this capital Q. You can consider any one, it's symmetric. So the force on this capital Q is due to this capital Q. So let that force be in the opposite direction. Of course, they will have the same sign, right? Same charge, positive positive or negative negative. So they will repel each other. Okay. Now capital Q. Now we have to balance this force, right? So small q has to be negative, because if it has to pull this, and the net resultant will be along this direction, and that is balancing the force. Okay. So that is the idea behind it. So capital Q by small q, one of them has to be negative. Okay, they have to be of opposite charge in order to balance this system. Okay, so this option B, which is giving a positive answer, is not the correct one over here. Okay, the two charges capital Q and small q have to be negative. Okay, now one thing we can do is resolve this F due to capital Q along and perpendicular. Okay, so if I this along, so this is 45, right? Because this is a square, this is 45 degree. So we can see that this will be also 45, right? Vertically opposite. So we can resolve it. Here we'll have f cos 45, and here we'll have f sin 45. So we have resolved this. So this is gone. Okay. So now you can see it clearly that f sin 45 is balanced by this force, and f cos 45 is balanced by the upper charge. Okay, so you can equate any one of this and reach to your answer. Okay, let's equate this force. F is equal to f due to capital Q and small q is equal to f sin 45. Okay, so f due to this capital Q and small q is k q q. You can use the minus sign also, and the difference between them, let us consider this distance as a. Okay, a square. Now the force between this capital F is, this force is due to between Q and capital Q. Okay, this force. Okay, so k q q by this distance is the diagonal, which is a root 2 the whole square. Okay, now and also sin 45, which is 1 by root 2. Here q and q are of opposite sign, so we'll use that. Okay, these two are of the same sign. Okay, minus minus will make it plus, or plus plus, keep it plus. Okay, so here it is plus and minus. Okay, as we have seen the logic over here. So k and k will get cancelled. One of the capital Q's will get cancelled. A square is going to get cancelled, and in the here we'll have, we want to find capital Q by small q. So capital Q is over here, small q, bring it over here, and in the denominator we have 2n root 2, right? This will become 2 and this is root 2. So this will go in the numerator, right? Numerator, and minus sign on the other side. So 2 root 2. The ratio is minus 2 root 2, which is option D. Okay, I hope the approach is clear. So that is how you do this question. Okay, let's come to this. Here we have a mosquito sitting at point O. Okay, we see a mosquito, why not kill it, but make a question of it. Okay, and then we have a glass rod of refractive index is given. It has some spherical end. The curvature is 40 centimeter. Okay, so this is a question based on refraction at spherical surface. Okay, so the formula is very straightforward, and you can directly find it using that formula. You just have to be careful about the sign convention. So mu2 by v minus mu1 by r upon mu2 minus mu1 upon r. This is the formula. Okay, so you can see you just have to use the convention. So this is your mu1. Light is going from this medium to that. So this is mu1. Light is going in the second medium. So mu2 is this medium. Okay, so 1.5 divided by v, which is what we want to find. Where is the image? Okay, final image. So this is the object distance. Mu1 is your from where the ray is starting. U is the object distance. Object distance, you can see now distances are measured from the pole, right? So from the pole, it is in opposite direction of the incident ray. Opposite direction of the incident ray. So that is minus 20. Okay, so be careful about the conventions. Mu2 minus mu1. So 1.5 minus 1 upon r. R is 40, and it is like this, right? Like this, meaning it is a concave one, convex one, sorry, and this is 40 centimeters. Okay, and it is in the direction of the incident ray, in the direction of the ray, right? So it is plus 40. Okay, so now let us solve this. This is 1.5 divided by, this can become plus, right? This will be 0.5 divided by 40. Okay, is it? Are we missing something over here? I don't know. Let's see. So 1.5 upon v is 0.5 upon 40 minus 1 upon 20, or we can say 2 upon 40, right? So I am multiplying 2 in the denominator. So this will 2 in the denominator and numerator. This will become minus 1.5 minus 2 plus 0.5 minus 1.5 upon 40. So this, if you see, 1.5 and 1.5 get cancelled, and v will be equal to minus 40, right? Minus 40 centimeters. So opposite to this direction. So in the left direction. Okay, minus 40 in the left direction. This is right, this is left, right? So minus 40 in the left direction. Okay, so that is our answer. Over to the next one. 21 and 22 over here. In 21, it's a question from gravitation chapter based on escape velocity. Escape velocity from the surface of Earth is given as v, but you are going to project a body at 3 times v. Okay, from the surface. You are supposed to tell what is the constant velocity with which your body will move in the interplanetary space. Okay, so actually you can do it by the conservation of energy. So first of all, you can add the initial and the initial kinetic and potential energy that will result in the final potential and final kinetic energy. Okay, because it is escape the gravitational field of Earth. Escape velocity by definition is greater than that, right? So it will escape the binding potential. Okay, so there will be no potential term over here. It's basically escape to infinity. So potential at infinity, 0. Okay, so let's come to this kinetic energy, initial kinetic energy. So half m to 3 v e square, right? Half m v square. So this is the velocity given, and potential energy, it is in minus, right? Minus g m by capital R. Okay, on the surface of the Earth, right? So on the surface of the Earth, we have the distance as capital R, right? So minus g m by capital R, and final kinetic energy half m v square. Okay, so from there we have to find v. Okay, so here actually you can see that this is nothing but half m v square. Okay, if you are a genius, this is 9 times half m v square. This is half m v square, because potential energy becomes equal to half m v square. This is the concept of your escape velocity, because these two terms will cancel out each other, hence the final energy is 0. So at that point where the final energy becomes 0, that is the amount of energy, that kinetic energy you need to supply for escape velocity. Okay, so that is the concept. I know it's a bit ooh. Okay, so we'll do it by the standard way. Okay, we'll do it the way we can understand it. So this is 9 times half mv square. I meant this was half mv square, so 9 minus half mv square, so that is 8 mv square. And so v square will be half m cancel, v square will be root of 8, which is 2 root 2. Okay, but anyways, let's do it by the actual way. Okay, some easier way. So gm, we know that in case of what gm is gr square, right? So we can substitute that. So gr square, or we can substitute gm by r as gr. Okay, simply gr. So this is mgr, right? And this will be half m v square. Now we can cancel this, and what will be left with? So we can multiply 2 also. So nve square minus 2gr, and this is v square, right? 2gr is nothing but under root 2gr is escape velocity, right? Root times gr. So under root 2 gr is escape velocity. So that is what I meant, right? This term is nothing but your escape velocity. It corresponds to escape velocity. It is the energy related to escape velocity. Okay. So this is 9v square minus this is v square, right? So this is v square. This is 8ve square is v square, which means v is 2 root 2 root 8, meaning 2 root 2 ve. Okay, 2 root 2 v. Okay, so this is the amount of energy which is left. Using that, it can perform the motion. Okay, so that will have energy or velocity 2 root 2 of the escape velocity. Okay, here we have light which is of this wavelength, which ejects a photoelectron, so dual nature of light. And here we have the work function of metal as 2 electron volts. Now we are also applying magnetic field in this region so that we can make this electrons go in circle. Okay, so this is the magnitude of magnetic field applied parallel to the plate. What would be the radius of the path followed by the electron? So you are supposed to find that radius with maximum energy. So maximum energy, we have the formula, kinetic energy max will be the energy that you supply, which is hc by lambda. Okay, and actually we can use the, since everything is in EV, we can use the shortcut. You can remember this 2400 by lambda in angstroms. Okay, this will give you energy in EVs. Okay, this gives you energy in EV. And work function is 2 EV. Okay, so 12,400 by lambda, which is 1,800. This is in nanometers. To make it in angstrom, multiply 10. So this and this can get cancelled, and you'll get a certain value. This is I think 2 nines are 2 6s are and 2 2s are, right? 62 by 9, so 9 2s are 18. 62 minus 18 by 9, 62 minus 18. Okay, 62 minus 20 is 42. 42 plus 2, 44 by 9. Okay, so 44 by 9. So that is your maximum kinetic energy. Now I'll just tell you the way. I know it is calculative. I chose this question because it is a composition of two concepts, right? This is your photoelectric effect, and this is your motion of charged particle in a moving magnetic field or changing magnetic field. Okay, so here we have found the kinetic energy. From here we can find V. So because for R we require mv by qb, right? We require V, so we can equate this kinetic energy to half mv square, which is 44 by 9. So we can from here we'll find V. Okay, m is mass of electron. Okay, so half we know, m we know, we can find V. So here, from here we'll find V. Okay, and that's V will substitute in mv by qb and get the value of R. Okay, this is an exercise. I'll leave it to you. Okay, do let me know the answer in the comment section. I know it, but you tell me what is the answer you get to. Okay, I know it's a bit calculative, but again you can use approximation. The answers are slightly far apart. Okay, so you can use reasonable approximations. Okay, so that's about this question. Over to the next one. Coming to question 23 and 24. In 23, it's a question from ray optics based on dispersive power. Okay, So here we are given the focal length for red color and blue rays. Okay, so you are supposed to tell the dispersive power. Okay, dispersive power by definition you can say it is FB minus FR minus FB upon F of yellow. Okay, focal length for red minus blue upon the mean focal length, which is the yellow one. Yellow one can be obtained simply by the geometric mean of your red and blue. So under root FR times FB. Okay. So let us find the yellow one first. So that will be FR is 100 and this is 96.8. Okay, so this will be 9680. 99 is 9801. 98 is about 96. Okay, 98 is about 9604, right? So it is close to 98. Okay, so you can take it as 98, or if you see the options are a bit apart, so we can also take 100 if you want. Later we'll see. It's about 98. Okay, so FR is 100 minus 96.8 divided by 98. Okay, so this is 100 minus 96.8, that is about 3 and 0.2, right? 3.2 divided by 98, or we can say 3.2 divided by 100. So that will give us 0.032 something, right? So 1 2, right? 0.032, so which is option C, right? 0.032. Okay, it will be 5 because we have considered 100. Okay, so 0.0325 is the correct choice over here. Let's come to this one. Here nucleus splits into two parts having their velocity ratios in the ratio v1 is 2 and v2 is 1. Okay, what will be the ratio of their nuclear radius? Okay, v1 by v2 is 2 is to 1. You are supposed to tell r1 by r2, which are their nuclear radius. Okay, so since the nuclear splits, we can say initial momentum is final momentum. Okay, it's internal process, so initial momentum is 0. It is initially at rest, right? The nucleus breaks into its constituents, the daughter nuclei, because of some internal process. Okay, it's not in motion initially. So the final momentum will be m1 v1, the daughter nuclei first, and the second one plus m2 v2, right? So you can see that m1 v1 is minus m2 v2. Okay, or forget the sign, it just says that the two will have velocities in the opposite direction. So m1 by m2, that is what we are supposed to find. We are supposed to find r1 by r2. Okay, we'll reach from here. Okay, we can say it is v2 by v1. Okay, v2 by v1, so it is 1 by 2, right? v2 by v1, v1 by v2 is 2 is to 1, v2 by v1 is 1 by 2. Okay, so now mass is proportional to mass number, of course, right? Mass is proportional to mass number. Okay, so more the number of protons, more will be the mass number, right? So mass is proportional to mass number, so a1 by a2, so this also will be in the ratio 1 by 2. Okay, since both of them are proportional, a1 by a2 will also lead to 1 by 2. Okay, why did I bring a over here? Because you know that r is equal to r0 a to the power 1/3. Okay, so we can take power 1/3 on both sides, so this will become r1 by r2. We can take power 1/3 on both the sides. When we take power 1/3, it becomes proportional to r, right? So a to the power 1/3 is proportional to r. So if we take power 1/3 on both the sides, it becomes proportional to r. So a1 by a2 power 1/3 is r1 by r2. Okay, simple logic. So 1 by 2 raised to 1/3. And where is that? In option B. Option B, 1 is to 1 or 2 by 1/3. So that is your ratio of the nuclear radii. Okay, few more questions to go. So let's roll. Question 25 and 26. 25, a wire of certain length is stretched slowly by 10%. So the new resistance and new specific resistance will be. Now the specific resistance is resistivity basically. Okay, so if you know resistivity does not change, right? Resistivity is a function of the material. It also depends on temperature and a few other intrinsic factors. So if you stretch a wire, it is not going to change. It is made of the same material. Even when you stretch it, of course the material is not changed suddenly. Okay, so the specific resistance will not change. Okay, so either option B is B or C. Okay, both remain same, or the resistance will change and the resistivity will remain same. Okay, you can do this question without solving. That is what I am saying. And if you know, the resistance will change because the length is changing, area will also change. Okay, they will not counteract each other, rather they will add up to each other. Okay, area, since you are stretching the wire, resistance increases and area, cross section area, will decrease. The wire will go thinner. Okay, thinner, so A will decrease and L will increase. Okay, so area is in the bottom, length is in the top, R is equal to rho L by A, right? So they will add up to this. Okay, so the resistance definitely will change and the resistivity will remain same. Another option, the resistivity is changing or both are remaining same, which is not the case. Okay, now let's actually solve it. Okay, you're not here for jugaad. So the length is increased by 10%, so L is increased by 0.1, which is 10%, 10 by 100, right, of L. Okay, so the length becomes 1.1 L. Now the volume should remain constant, so the area should become, since length becomes 1.1 times, area should be divided by 1.1. Okay, length becomes 1.1 times, then area should be divided by 1.1 times. So R dash will become rho L dash by A dash. So L is, if you see, 1.1 times L upon area is 1 A upon 1.1. Okay, so if you see 1.1 times 1.1 into rho L by A, this is nothing but the original resistance, and this is 1.21. Okay, 11 11s are 121. So this is new resistance is 1.12 times old resistance. Okay, and the resistivity, as I told you, will remain the same. Let's come to this one. Here we have 6 amperes being superimposed. This is a direct current which is superimposed on a AC current. You are supposed to tell the effective value of the current will be. Okay, actually you can use the average value equation. I also don't remember it exactly, so I think it's somewhat like I square dt upon dt from 0 to t, something like this. Okay, so you can use this, or you can basically take the RMS root values of this two values. Okay, I'll do it by that way. So the effective current will be RMS I1 RMS square plus I2 RMS square. Okay, root means square of this two effective values. One dealing with the direct current. Direct current, the RMS value is equal to the peak value is equal to the constant value. Okay, the constant value is itself the RMS and the peak value. Okay, so RMS value is 6 square. Okay, and for the wave, RMS value will be, this is I naught, right? I naught is 10, RMS will be 10 by root 2, right? Root 2 times the peak value. So 10 by root 2 the whole square. Okay, so we'll have 36 and we'll have 100 by 2. 100 by 2 is 50. So this is about 86. 86, 81 is around 9, right? 86 is around 9.27. So 9.27 is the correct choice over here. You can do it also by that way. Do check it out. But that's about this question. Over to the next one. Question 27 and 28 over here. In question 27, we have a pulley of radius 2 meters. Okay, and we are applying force tangentially to it, and the force is dependent on time, 20t minus 5t square. The moment of inertia of this ring or pulley is given to be 10 kg per meter square. The number of rotations made by it before it changes its direction. Okay, so you can see the force is somewhat like a parabola, so it's going to increase for a while, and after a certain point it is going to go maximum and then decrease. You can take the derivative and see at what point it is maximum, and later it is going to decrease. Okay, so the basically eventually the pulley will change its direction. You are supposed to tell how much rotations will it make before it changes its direction. This is a good question. Okay, so we'll start with moment of inertia is given, force is given. Okay, so I can think of tau is equal to R cross F. Okay, force is tangential, so sine 90, okay, and this will be equal to I alpha. I is given, right? So that's why I'm using this. And what can we say? R is the radius. The force is applied at a distance of 2 meters. So 2 times F. F is 20t minus 5t square, and here we'll have 10 alpha. Okay. So 22s are 40, and we can divide this. 2 5s are 10, and that will cancel. So this will be 4t minus t square, right? That will be alpha. Alpha is nothing but d omega by dt. Okay. We are going to find omega, we are going to find theta, and theta by 2 pi will give us number of rotations, right? Because 1 2 pi corresponds to 2 pi degree change corresponds to a single rotation, right? So theta by 2 pi will give us the number of rotations. So this is d omega by dt. So for omega we need to integrate. Okay, so if we integrate, this will be t square by 2, t square by 2, this and this will get cancelled, this will be 2t square, and if we integrate this, this is t cube by 3, right? Now we are supposed to know the time at which the disc or the pulley will change its direction, right? That will happen if the angular velocity becomes 0. Linear velocity or angular velocity will become 0 at that point, right? At that point angular velocity will become 0, and then it will change its direction. Okay, so at that point make angular velocity 0. 2t square is equal to t cube by 3. So this will give you t is equal to 6. So at 6 seconds this will change direction. Okay, when angular velocity becomes 0, and the next instant it is going to become it is going to go in the other direction. Okay, so at t is equal to t seconds 6 seconds, it is becoming 0. Okay, that is the point at which it is going to change its direction. Now this omega is itself d theta by dt. Okay, I hope you are following. Okay, d theta by dt. So now again integrate, so you'll get theta as, if you integrate, 2t square t cube by 3. Okay, so this is 2t cube by 3. Okay, and then minus this will be t to the power 4 by 12. Okay, so this will give us if you substitute t is equal to 6 at t is equal to 6, because that is the time we want to find the angle. Okay, that is the amount of angle it has covered. So at t is equal to 6, it will give you about 36. Okay, you can substitute t is equal to 6 over here, it will give you 36. So your number of rotations will be theta by 2 pi. Okay, I hope you can see over here, or I'll write it over here. Theta is n is equal to theta by 2 pi. So theta is 36 by 2 pi. Okay, 36 by 2 is 18. 18 by around 3, it's around 6, right? 3 point something, so around 5 point something, 5.7 maybe. Okay, so 5.7, so that is between 3 and 6, right? It's greater than 3, less than 6. Okay, so that is how you approach this question. Let's come to this one. This is based on your atomic dipole moment. Okay, so some of you might directly know this answer, the ratio of angular momentum to the atomic dipole moment for hydrogen like atom. Okay, if you know this ratio directly, you'll know that the answer is constant and is equal to 2 times mass by charge ratio. We'll also derive it, it's a short derivation. So dipole moment is IA, right? Mu is equal to IA, current times area. Now this current is due to the revolving electron around your nucleus. So this current is due to Q by T. Okay, this Q is electron. So electron area will be, if suppose this radius is r, then area will be pi r square. Now what will be the time? The time will be the distance, which is the circumference of the circle, divided by velocity. Okay, 2 pi r by v. Okay, so 2 pi r into v. Okay, by v, so that goes on top. So pi and r will get cancelled. So we have EVR by 2. EVR by 2 is your dipole moment. Okay, now we want angular momentum, which is MVR, right? So we can multiply m on both sides. So mu m will give us m E by 2 into MVR, right? So MVR, that we can write as L. So we are supposed to find the ratio of L by mu. So L by mu, so L by mu will be 2m by E. So which is 2 times mass to charge ratio. 2 times ratio of mass to charge of electron. Of course electron, whole discussion we considered about electron only. So yes, this ratio is 2 times mass of electron, ratio of mass to charge of electron. Okay, so that is our answer. Over to the last 2 questions for the day. Question 29 over here. Where is question 30? Question 30 is your homework question. You'll let me know the answers of that in the comment section. So for now, let's do question 29, which will be the last question for our day today. Okay, so here a radioactive sample of half-life 23.1 days is integrating continuously. Okay, so humankind is dying. The percentage decay of the sample between the 15th and the 16th day will be, okay, E to the power 0.03 is 1.03. Okay, you are supposed to find the percentage decay between 15th and 16th day. Basically the percentage change. Okay, percentage change, whenever they ask you for percentage change, it is basically final minus initial, or initial minus final upon initial, whatever the difference is, positive difference upon initial. Okay, final minus initial upon initial. Okay, so that is what you are supposed to calculate. So at 15th day, at t is equal to 15, what will be the concentration? You can use the radioactive law, n is equal to n0 e raised to minus lambda t, right? T is 15 in this case, so 15 I can write 15 lambda. Okay, and at t is equal to 16, similarly we can write 16th day, so I'll write this as n1, this as n2, so this will be n0 e raised to minus 16 lambda. Okay, now lambda also we can find. Lambda is nothing but, since they have given us the half-life, it is 0.693 by t half. Okay, so this will be 0.693 by t half is 23.1. Okay, so if you see, this is 3 times, right? I can write this as 69.3 upon 23.1 into 10 to the power minus. So I multiply this with 3. If you see, 3 2s are 6, 3 3s are 9, 3 1s are 3, right? So this is 3 times. So 3 into 10 to the power minus 2, which is 0.03. That is why they have given us this. This is per day, okay? Day inverse. So that is why they have given this info. Okay, now percentage change, that is simple. Difference, which is n1 minus n2, we can do, right? n1 minus n2 upon n1. Initial minus final upon initial. Okay, that is what we are doing. So n0, we can take it common, e raised to minus 15 lambda minus e raised to minus 16 lambda upon initial is e0 e raised to minus 15 lambda. Okay, so this and this will get cancelled. Okay, so we are doing initial minus final. Okay, 15th day before 16th day, right? So that is how it is. Okay, not the other way around. So now I can do what I can do. I can divide this. So e raised to minus 15, I'll separate it out. So when I divide it with this, it is simply 1, and when I divide it with this, it is e raised to minus lambda. So this will become e raised to minus lambda is minus 0.03. Now we know the value of e raised to 0.03. So we can take the inverse of that. So 1 upon 1.03, right? E, this will be 1 upon 1 minus e to the power 0.03. So that is 1.03. So our answer will be 1.03 upon 1.03 minus 1. Okay, so this is about 2.9%, I think 3%. So that will be about 2.9%, which is option C. Okay, so option C is the correct choice over here. So quite straightforward. Just use percentage change as difference upon initial. So initial minus final upon initial. Okay, so that is how you do it. So over to your homework question. Question 30, this is your homework question. You can pause the video over here and take a screenshot. Okay, do try it and let me know the answers of this question in the comment section below. The correct answer receives a heart from me, And that's all about today's video. I hope you really enjoyed this grind and you'll join me for the next time with 30 more most probable questions for BITSAT 2024. Yeah, that's all about today. I'm signing off. Keep enjoying physics.